The next participant is our dear Ulrich Hoffmann from Hamburg, and he will present something that all people in this community are asking. Please, Ulrich, explain us tutorial data structures, because we want to know more about this. And this is Let's Go for Objects.
Okay, right. Yep, let me see. I will share my desktop and right, so where's the presentation? Here we go. I had some previous talks about data structures, and we looked at how to realize records, structures or arrays in Forth, either in RAM-ROM systems or in virtual memory, and things like this. And so this is the ongoing schedule. Before last time we looked at Forth arrays and how to do with this, and I promised to come back to structures and records so that we can also have a look at how objects might be realized in Forth. And if you remember the structures, we had fields in there and we stored data in them. We did the address calculation either by hand or by using a defining word. And well, let's talk today about how we can extend this very easily to also deal with object-like structures. So, and for this, I will first talk a little bit about data and code. And if we think about how code is referenced in, or can be referenced in Forth, then we will come up with execution tokens or the code field address, or maybe the name field address, or whatever, something that allows you to refer to a word so that you can put it on the stack, put it in variables, and finally execute that word. So within standard terms, this is the execution token. And we will talk a little bit about variables and also the defining word deferred words, execution vectors that can hold a reference to a word. And when they are executed, they essentially execute their reference. And so that's something that you can read up in the beginner's books as well. And well, of course, we want to see how can we bring this together with the structs, the records that we saw earlier. Can we have execution token in structures? Yes, of course. And then we will have not only data within our structure, but we will also have behavior words, or you can call them methods if you want to, inside a structure. And thus it can behave like an object in other languages. And again, as we normally do in Forth, you will build these things on your own. So if you get a Forth system right out of the box, it normally doesn't have all these structures. So you can go ahead, if you know what you're doing, go ahead and build the appropriate object-oriented structures, data and code together in your Forth system, depending on the application needs that you have. If you do not have just a single behavior that you want to attach, then of course you can just add up fields with more execution tokens in your structure, or something comes up that is the so-called virtual method table, and we will have a look at that as well. So let's talk about data and code in Forth. You have to plan all the memory layout and all the techniques to implement this on your own. Hopefully there are people that can tell you about it, and you can read it up in good textbooks. You can also pull something from a well-used established library, or you use a Forth system that provides all this already. So in Forth, we store normally things in cells. either it fits in a cell like a character or signed, unsigned integers, or it doesn't fit in a cell, then we use several cells to store the data that we want to. So part of the data is stored in a cell, and we arrange all this on our own. And during the course of the talks I gave, we looked at arrays and structs and how we do this. So it could be measurement data, or it could be dates, or it could be temperatures, or whatever. It could be statistical data, sound information, or whatever the data is that you're dealing with. So that's not unusual. You do this in every programming environment. In Forth, we can also store execution tokens and refer to words, as I said. Different Forth systems use different ways to reference this. So in the early days of Forth interest group Forth, it was the parameter field address or the code field address that you would use for referring to a word. Today, it's all abstracted away in the standard discussion, calling it an execution token. So it's some number that is just a good identifier for a word. And you can tick a word to get that identifier, and you can execute the identifier to actually invoke a word and execute it. Yeah, we all know about that. And so because of this, you can store these execution tokens in variables. And that's what we will do here as well. I have a small example, a variable greeting that holds the execution vector of the word that will do the actual greeting in our system. And we have two different behaviors that this might have. So it could be night, or it could be day. And so whenever I want to have some greeting, it will be executing night, or it will be executing day, depending on this. And then I have two words, dawn and dusk, that store the appropriate execution token in the variable greeting, depending on whether it's dawn or dusk. And then I have a word that actually extracts the execution token from the variable and executes the appropriate function, the appropriate word that is in there. So with this setup, I can say dawn greet, and I get hello, because in the morning I'm happy and I want to greet everyone with hello. And if it's dusk, sundown, then I say dusk greet, and then I get good night. So dawn and dusk switch the execution vector that is actually stored in greeting to either day or night, which will eventually, when executed, print out the appropriate things. So that's very basic Forth. You only need a tick to get the execution token of a word, and you need execute to execute this. All other things are done with fetch and store, like we deal with normal variables all the time. Then maybe you don't want to do this because, well, you have to execute this value explicitly, and you don't want to have this. You want to hide it in somewhere, in some way. And this is typically done with a defining word on its own. So you have variable-like things where you can store execution tokens, but that actually, when you just name the word, it will go ahead, fetch the execution token, and execute it immediately. And this is what the word defer normally does. And you do things very similar. Instead of variable, now you do defer greeting. You use the same words as before. And then because if you just say greeting now, it will try to execute what its content is. You have to somehow have special fetch and store operators. That's what you get. So here's a defer store that you can use for storing a execution token in a deferred word. Or some Forth systems use the is syntax to do it. So you say tick bracket tick day or tick day, as before, is greeting, or the way I did it here, bracket tick day, bracket tick greeting, defer store. So this is more complicated, but using the deferred word and executing what's in it is more easily done. You just name the word. And of course, you see here, greet is just greeting now, and we could just call the deferred word greet, and then we could just get rid of one word. The usage is essentially the same as it was before. So we can have this defining word, and it's very easy to define it. So instead of just putting the address of the variable on the stack, it will just go ahead and fetch and execute what is in there. And defer store will go to the appropriate parameter field and store the value in there. So that's what it is. Right. So that's that. And now let's see how can we combine this with the records that we saw earlier, or the structures that we saw earlier. This is a review of an old slide that we saw in one of the previous talks. It defines a structure using the plus field record that defines words that actually do address arithmetic, starting from a base address, add an appropriate offset so that you can go from the beginning of the structure to the appropriate cell where the field is stored. So X actually does nothing. It leaves the address unchanged, but Y underscore Y actually in a 32-bit system does a 4+, so that after executing underscore Y, it calculates from the base address to the beginning address of the appropriate Y field. And all this does the calculation. So later on, you know, when you are at the end of the definition, how large the new structure is, and you can just create it so that you can later on use it for allocating appropriate space. So this is also in the meantime, it's the standard way to define structures and to do this. And then you can store different things without further being aware of the memory's layout. You can store a 3 in the X field of the record, and you can store 4 in the P field of the in the Y field of the record, and then you can do some calculations on it. And so that's what we already saw. But now we want to add behavior to the forth structure, and we do this. For example, now we have a point, and we want to plot the point on screen or on a display, as Peter showed us the last time. We want to plot the point somewhere. And now we add another field, and this field actually contains the execution token of the function of the word that will actually go ahead and does it. This execution token will have a stack effect. It will take the structure address from the stack, and it will just carry out what is necessary. Maybe in other behaviors, we will have additional parameters, but it's very typical that we get the reference of the structure so that we can access the appropriate fields in it. And a typical way to do it is we get the X coordinate from the point, we get the Y coordinate from the point, and then we invoke some graphic primitive that is able to plot on screen in a canvas or whatever we want to do. And that's the execution token of that word is actually what we want to store inside that field. So later on, we can go ahead and execute it. And because the execute is normally explicit, like in the variable case, we need to fetch and store the fields in the setup that we have. It's better to have another word that will do the fetch execute on its own. So we define the word plot, which actually extracts the execution token from the first field and execute it in a way so that the point address is still on the stack. So that satisfies the stack effect that we have here. And so then we have a structure that has one field more. I added this at the beginning. So we have the execution token of the parent plotted word in there. We have the x coordinate and the y coordinate in there in the next field. So 3 fields actually. And if we do plot on it, it will extract the execution token from the first field and invoke it. And the function plotted itself will extract x and y and essentially call the appropriate drawing primitive. So after we did all this, we store the coordinates. We can just say p-plot. And then it does the magic that I just described. It will go ahead and plot the appropriate point there. Whoa, right. So that's something that that we can easily do. It's only fetch and stores and execute. So nothing more fancy than this, but used in a clever way to actually do this. And well, maybe not so nice is that we need to define a colon definition for every execution vector. And similar to variable and defer, maybe we want to have a defining word that is not just giving us the address, but also does the execute on its own. And this is the next thing that we do. We say, okay, maybe we have some defer-like fields in our structures. And so we use a new defining word, which we'll just see in a moment how it looks like, plus defer, similar to plus field, that defines a field that executes its execution token whenever we put some data in it, or whenever we invoke that word. And because we also want to store values in it, it's good to have to keep the name underscore plotted to access it in a variable-like way and plot it to execute it. And we can easily do this by influencing the address calculation. So if we do 0 cells, then it wouldn't change the address calculation, and only it only gets incremented with a 1. So essentially, it's an alias for the same field, but plotted without the underscore in front will execute what is in there, and underscore plotted will return its appropriate address. Ooh. And similar, so the main effect is that we don't need the fetch execute anymore, because it will be the execution part of the deferred word. So let's see how this looks like. Plus defer looks like it's actually a field, but instead of leaving just the address there, it goes ahead and fetches the value and executes the appropriate thing. So I'm not quite sure. Yeah, it works. Maybe it needs to do address calculation. I'm not sure, but you get the idea. So let me see how this works. Okay. Right, and then we allocate the point as before, and we can use it as before. We store the appropriate execution token in there, and then we can just go and use it the same way as before. So the idea, variable and defer, and field and plus defer, that's the idea of doing these things in this way. So we can add behavior to our for structures, which means yeah, we have additional fields with execution tokens in there that operate on the data that is there. So we have behavior and we have data, code and data side by side in our structures, which is essentially objects. And so let's see. What if I don't have a single behavior, but I will add more behavior, like move the point to some other location, for example. And I don't want to do this or copy a point or draw a line between a point and the origin or whatever additional behavior I might want to have, not a single one. What I can do is similar to this. I add another field beside plot it and x and y, and then just augment my record with the appropriate execution tokens. But what I also can do, and this is sometimes reasonable, if many common structures share the same behavior and only are different in the data part, to instead of adding more execution tokens in the record itself, add a table of execution tokens and just refer this with with the address that is stored there. And that's a technique that is called the virtual method table, the way that C++ does object-oriented programming. So the objects in C++ will just have virtual method table references in the first location of the structures of the object that you use. And so instead of executing the value directly from the field, you have to follow the indirection, and you have to index into the virtual method table to get the appropriate things. But this way, the address of the virtual method table can be shared with all objects that are alike and share the same behavior and are only different in the X and Y in the data that you have. So if you will build this, then it changes. So you don't have the execution token here, but a reference to the virtual method table. And you build up a virtual method table where you store the execution tokens appropriately and you initialize the object appropriately. And then you can just go ahead and do the same thing. So the virtual method table actually adds an indirection and some indexing to the calculation of the appropriate execution token, and to make it more versatile, more reusable. But for simpler cases, it's very reasonable to just store the execution token in a record and then execute it in the way that I presented. Right. And so if you are interested in this kind of things, then it's probably a good idea to have a look at mini-oof, mini-oof2 or Bernd-oof, the three systems that Bernd Peisan presented many years ago over the time. Mini-oof is a object-oriented Forth extension in a single screen. oof2 is a little bit different, this a little bit more elaborated, and Bernd-oof actually introduces the notion of an object stack. So because you see here, it's very difficult. You have this reference to the current object, to the current structure, and you have to have it on the stack, and you always need to deal with it. And you have the data that you extract, but you need to somehow keep the reference. And this could be cumbersome. And if the reference is actually on an object stack, then the code that resides in there will become much more easy to manage, but it will depart a little bit from standard Forth in that way. You have to define that object stack and manage it appropriately. Right. So let me conclude. Yeah, we looked at data and code. Forth is able to store and manage both by the means of execution token. You can refer to words and their behavior. You can store it in variable and deal with it. Many systems do this with the IO system, for example. So they have variables that hold the word that actually does the printing of a character or reading of the keyboard. And if you want to divert it to some other place, you just store different values in these variables, or you can use defer to actually do it in the same in the same spirit, but in a different way, by having the execute implicit in the defining word. And you can do the same trick with structures. You can store execution tokens directly there, or you could do auto fetch and execute fields that actually go ahead and execute the word that is stored in the field. And then if you want to share behavior between objects, then you would go for a virtual method table. Wow. So this, to conclude everything, sums up and completes the data structure part. So we looked at earlier, we looked at structs, we looked at different flavors of arrays. Now we have object, we also looked at enumeration types. And yeah, so that's actually what's I think is in there. And in typical applications that are more complicated than just start applications, in one way or the other, you will need to define structs or arrays or maybe enumeration types, but probably also objects if it becomes more difficult. And so it's probably a good idea to know how these things work. And yeah, so this brings me to the end of my talk, and I'm sure there are questions. I will bring up all the slides of the talks that I did previously, and this one also on the GitHub Forth2020 repository, so that you can refer back. And of course, this is recorded. You can go back and watch the recording. And yeah, but I'm still open for questions, of course. So that's it. Atle, thanks for the thumbs up. So please do not hesitate, open the mic and
wonderful, Ulrich. Fantastic.
Questions.
That's great, Ulrich. Can you put some links on for the mini oof and burn and all that?
Actually, I think it's very easy to Google it, but I will do it, and the link that I get, I will just put in the chat.
Yeah, I just tried to Google it. It's not.
Oh, okay, right. Yeah. Okay, maybe I'm more successful than you are. I will do.
Ulrich, let me ask. I'm Matteo. Hi. I think that the first version of the point has a redundancy because you repeat the execute address in every object you define later. While when you use the virtual table, you are acting very object-oriented. Like I think there is. I got it this way, I think.
Yeah, you can actually do both. It really depends on whether you have very similar objects that are in the same behavior and are only different in the data that you work on. And in typical object-oriented systems where you have classes, then the class actually captures the behavior of all the objects that belong to that class, and they only are different in the values that they hold. And then you would go for this virtual method table implementation.
I don't say that is wrong or right. Both are good in what you are doing, you are wanting to do. Yeah, exactly. This is
exactly. Yeah.
Exactly.
Yeah. And the first option is often if you have something that is some systems are called said to be object-based. So the object stores all the information that is necessary to hold it. There is no class at all. And then something like storing the execution tokens over and over again, even if it's the same behavior in the objects, then that's the way to go. And I think, yeah, we have the choice. In Forth, we have the choice. If you are a C++ programmer, then your object-oriented programming is virtual method table. And or early binding and resolving everything, but your object implementation is virtual method table, and you have no choice. In Forth, you have the choice. You can also just store things in fields, and it comes up with in the end it comes up with the same syntax that you can use. It just
anyways, as always, Ulrike, you bring in this discussion very good ideas. Thank you.
Thank you very much. Yeah. Right. Are there other questions?
Christian again. I think I'm going to slip one.
Yeah.
Ulrich, in ESP32 Forth APIs that are built as a big binary blob inside the ESP32, they frequently require a structure as a kind of pointer to all the data that will be used by the API.
Mm-hmm.
I'm always having a hard time to create this structure. Could it be created in Forth and then pointed to as one pointer in the API? Because the API requests a pointer to the structure.
Yeah. So the structure typically is defined in C, I guess, if it's ESP32 force and if it's in the blob. So you have to see how is the memory layout that the C compiler will do for the structure. Yeah, and if you understand it and you know how the memory layout is, then you can use this technique of creating force structures with the appropriate fields. And essentially, it will mainly be whether you have one cell or two cells or whatever, or just a single character in the fields. And if you match, you can do it in this style. If you match the structure of your record with what the C compiler expects, then you can just pass in P, which is the address of the beginning of the memory region, and that will work.
So more or less, I either do it in C,
yes,
the proper structure for what I want to do,
yeah,
or I could do it in Forth and just pass the pointer to that structure.
Yeah. The challenge really is to define the force structure in a way that it has exactly the same memory layout that the C structure assumes.
Yeah, the API describes the structure in detail.
Yeah,
I will add something for Christian understanding. We have structures in ESP32 force, Christian, and we also have the OAuth of Bernd Python implemented by SuperBob on the ESP32 Forth site. If you enter the ESP32 Forth site of the group, you will find structures are there, and they are not compatible to the GNU C compiler. This is different. This is different. You cannot do that. But in C, when you pass one function, the structure, to another one, many times you are passing this also over the stack, the same as it happens in Forth. But you need to work with the stack. You need to think in Forth, and you need to see. You cannot copy something from C into Forth. You need to think in Forth and on the Forth stack.
Yeah, but that means I might have a hard time using the APIs that are built in the ESP32.
No, Ulrich explained to you. You can pass a pointer also. You can pass a structure or data structure by a pointer.
Yeah. So, and if it's easy or difficult depends also on the complexity of the structure. So if it's just like this with two fields, and then it's quite easy to repeat this in Forth and then pass it in. But C structures could also be very complicated with alignment.
It can be a structure inside another structure,
and lots of things. So it really depends on the special case, I guess.
It sounds like it'll be better to do the structure in C and just use it.
So that's
thank you.
Could be less error prone. Yeah.
Also, keep in mind that depending on environment and your compiler settings, your structure layout in C will change. You can optimize for speed, you can optimize for size, and compilers have gotten really good at mixing things up. When you do that, that means if you have a mix of environments, Forth and C, depending how you parameterize your compile, your Forth part might access regions that used to be there, but courtesy of the compiler being told to do something different, are not right now. We need to be really careful with that. Right. It's doable, but it's messy. It can be messy. If you don't maintain it properly, it will be messy.
Yeah, the solution is if you want to communicate with other languages, you are bound to use things like int 32, float 64, and otherwise you it doesn't work, especially if you change the options for the C compiler.
Mhm.